scattering freely move করছে unless and until there is no deviation from periodicity, কোনো ডিফেক্ট, কোনো ইম্পিউরিটি কিচ্ছু নেই তখন, এবং দে বিহেভ অ্যাজ মলিকুলস অফ পারফেক্ট গ্যাস। সেই জন্য আমরা টু ইলেকট্রন কন্ডাকশন ইলেকট্রন সিস্টেম বা হোল সিস্টেমটাকে বলি ইলেকট্রন গ্যাস আর হোল গ্যাস, এইভাবে রিপ্রেজেন্ট করা হয়। তার মধ্যে 2Dটা এলো এই জন্য যে একটা হেটারো জাংশন করলে আমরা দেখছি রাইট অ্যাট দ্য ইন্টারফেস ব্যান্ড বেন্ডিং occurs due to charge transfer across the interface. Some space charge will be developed on either side, এবং যেখানে ধরো চার্জ অ্যাকুমুলেশন হলো সেখানে ব্যান্ড বেন্ড করে so that it appears as a, we can treat it as a triangular potential well. Now width of this potential well becomes comparable to electron wavelength, then we call it a quantum well. তার মানে in the transverse direction, মানে along the direction of the width of the well, it is so thin that as if one dimension of the system is lost. We will assume this as a two-dimensional system. So electron motion is also restricted along that direction.
ম্যাম
হ্যাঁ, দাঁড়াও, জাস্ট আমি একটা না আঁকলে তোমরা বুঝতে পারবে না। এটা তো ভার্টিক্যাল হবে। So this is the structure. So this is the delta EC. এই যে এইখানে
ম্যাম আপনি স্ক্রিন প্রেজেন্টিং করেননি।
ও আচ্ছা, তাই তো, আবার অ্যাডমিট করতে অসুবিধা হয়। এবার ঠিক আছে, দেখতে পাচ্ছ? সো এই যে ব্যান্ড বেন্ডিংটা হলো অ্যাক্রস দ্য ইন্টারফেস অফ আ হেটারো জাংশন, তার মানে এইটা ধরো এন ছিল আর এটা ইন্ট্রিনসিক ছিল, দুটো ডিফারেন্ট মেটেরিয়াল, we form the junction. So electrons from this side will come to this one, lower band gap semiconductors. So in this region, in the smaller band gap material side, adjacent to the interface, এখানে ব্যান্ড বেন্ডিং এমন হলো কারণ এখানে ইলেকট্রন কনসেন্ট্রেশন বেশি, so it appears as a triangular potential well for the electron. তাহলে এই যে ডাইমেনশনটা ওয়েলের, if it is very thin, if this doping is high for this region, doping is high, তাহলে ব্যান্ড এইটা very thin হবে। তাহলে এইটাকে if this width of this well is comparable to electrons de Broglie wavelength, then it will behave as a quantum well. That means basically this direction is restricted. So electrons motion in this direction is restricted. It will be quantized. But in this perpendicular transverse plane, এটা যদি আমি এই z direction ধরি, normally আমরা z direction টাই ধরি as growth of nanostructures. So this is z. So xy plane, electrons has no problem for their motion. So the electrons has lost 1 degree of freedom. So it is as if a two-dimensional. So electrons in such system is called two-dimensional electron gas. Same thing for holes in valence band. সেই জন্য আমরা 2DEG 2DHG বলি। ক্লিয়ার?
হ্যাঁ ঠিক আছে।
আচ্ছা, নেক্সট কেউ কিছু বলছিলেন?
হ্যাঁ ম্যাম, আমি জিজ্ঞাসা করছিলাম যে আমাদের সেমিস্টার এক্সামের মানে কিভাবে আসবে, মানে কিভাবে হবে ওটা, মানে
সেমিস্টার এক্সামটা
মানে ইলেকট্রিক্যাল দিতে যেমন বলছে ওদের ওই সব কটা পেপার একসাথে দিয়ে দেবে, তারপরে 10 দিন সময় দেওয়া হবে, সেরকম ইলেকট্রনিক্স এর কেমন কিভাবে নেওয়া হবে?
এইটা ইন্ডিভিজুয়াল অ্যাটলিস্ট ফার্স্ট ইয়ারের বেলায় এটা ডিপার্টমেন্ট টু ডিপার্টমেন্ট ভ্যারি করার কথা নয়, বিকজ ইট ইজ কমন কোর্স। ফার্স্ট ইয়ার তো এখন কমন কোর্স, কাজেই এইটা সেন্ট্রাল কমিটি ডিসাইড করবে। মোস্ট প্রবাবলি, জানি না, এখনো ডেট ডিক্লেয়ার করেনি, এই ফ্রাইডে হয়তো আমাদের যারা কোঅর্ডিনেটর এই কোর্সের বিভিন্ন ডিপার্টমেন্টের, যেমন তোমাদের কোর্সটার জন্য মডিউল বি আমি কোঅর্ডিনেটর, তো এই মিটিং সেন্ট্রাল মিটিং এ ডিসাইডেড হবে, এখনো ফাইনালাইজড হয়নি। মোস্ট প্রবাবলি এই উইকে ফ্রাইডেতে হবে, যদি না হয় কামিং উইকে তো ডেফিনেটলি হবে। একবার ডিসাইডেড হলে আমি তোমাদের জানিয়ে দেবো। তোমাদের একটা অ্যাংজাইটি রয়েছে, সেটা আমি বুঝতে পারছি।
ঠিক আছে,
ঠিক আছে,
হ্যাঁ ম্যাম, ঠিক আছে।
এবার আমি শুরু করি অরিজিনাল ক্লাস।
আর ম্যাম কয়েকজন না ওয়েট করছে।
ও, আজকে তো ইউজিটি পড়ানোর কথা, ইউজিটি তো কমপ্লিট হয়নি। কিছুতেই শুধরাবে না, 10টা 7। মার্চ মাসে তো ডিজলভ করে যাবে থিওরিটিক্যাল সেশনাল সবই।
ম্যাম আরেকটা জিনিস ছিল, মানে এমন যদি কখনো হয়, মানে এই কম সময়ের মধ্যে কোনো টিচার হয়তো কোনো পার্ট পড়াতে পারেনি, মানে সিলেবাসের মধ্যে রয়েছে পার্ট পড়াতে পারেনি, তাহলে করে সিলেবাসে মানে কোশ্চেন পেপারে কি আসবে ওখান থেকে কোশ্চেন?
না, সেটা আসা উচিত না। আমারটা তো মাত্র 2জন, whereas মডিউল এ তো বাদ বাকি সব ইঞ্জিনিয়ারিং ডিপার্টমেন্টের এক্সেপ্ট মেকানিক্যাল। তাহলে কতজন টিচার করে কমন ইন্টারসেকশনটা নেওয়া উচিত আইডিয়ালি। এবার কেউ যদি না স্বীকার করে, না আমি পড়িয়ে দিয়েছি, আমি বলে দিলাম আমি পড়িয়েছি, কিন্তু আসলে আমি কভার করতে পারিনি, সেটা তো কিছু করার নেই, তো চ্যালেঞ্জ করা যায় না, তাহলে ছেলেমেয়েরা একটু ভিক্টিমাইজ হবেই। আদারওয়াইজ নর্মালি আমি জানি না, ওই মডিউলটা নিয়ে আমি ইনভলভ নই। প্রত্যেকের উচিত, আমরা যে 2জন, আমি তার সঙ্গে টাইম টু টাইম কন্ট্যাক্ট রাখি, যে তুমি কতটা এগুলো, আমি কিন্তু এই করলাম, এবং একটা পার্টিকুলার টপিকেরও অনেক ডেপথে যাওয়া যায়। ডিজিটি আমি শুধু ক্যারেক্টারিস্টিক পড়াচ্ছি, আমি এই প্যারামিটার ইকুইভ্যালেন্স সার্কিট কিন্তু পড়াচ্ছি না, এইগুলো আমরা নিজেরা ডিসাইড করে নিই, পুরোটা যেন এফেক্টিভলি আমি সিলেবাসে মানে পরীক্ষার জন্য ইনক্লুড করতে পারি। যাদবপুরের তো ফ্লেক্সিবিলিটি খুব বেশি, মানে টিচার যা পড়াবেন দ্যাট ইজ সিলেবাস, অরিজিনাল সিলেবাসের থেকে এফেক্টিভ সিলেবাস হচ্ছে যতটুকু কভার করা হবে নর্মাল ক্ষেত্রে। তোমাদের জন্য আমি জানি না, তোমাদের ক্ষেত্রে যদি অ্যাসাইনমেন্ট হয় যে একটু রিলেটেড জিনিস পড়াইনি, সেটা অ্যাজ অ্যাসাইনমেন্ট দিয়ে দেওয়া হবে, সব আলাদা কথা।
এই জিনিসটা হচ্ছে অ্যাকচুয়ালি,
হ্যাঁ,
এই জিনিসটা হচ্ছে পড়ায়নি বাট অ্যাসাইনমেন্ট দিয়ে দেবে।
এখন কি হয়েছে, অ্যাসাইনমেন্ট দিতে গেলে আমি যা পড়িয়েছি এবার সেটাই অ্যাসাইনমেন্ট দেওয়া, মানে এ তো ভার্চুয়াল মোডে এবার পুরোটা কপি করে সবাই দিয়ে দিল, তাহলে তুমি কি করে ডিসক্রিমিনেট করবে? সেই জন্য একটা জিনিস পড়িয়েছি, এই যদি আমি এখন ইউজিপিটা পড়ালাম, রিল্যাক্সেশন অসিলেটরটা পড়াতাম না, তোমাদের অ্যাসাইনমেন্ট দিলাম কিভাবে এটা একটা অসিলেটর হিসাবে ইউজ করা, এতেও কোনো লাভ নেই, তোমার সাথে সাথে সার্চ দেবে, রেজাল্ট এসে যাবে 5টা, তার থেকে খুঁজে সুন্দর করে একটা দিয়ে দেবে। কিছুই তো আর আজকাল নেই তা নয়, করার নেই, সেটাই করা হয়, এইবার করা হচ্ছে। এতদিন তো ফিজিক্যাল মোডে হচ্ছে, সেমিস্টারে না পড়ানো জিনিস দেওয়া হতো না। ঠিক আছে, আমি ক্লাস শুরু করি। কেউ কি ওয়েট করছে এখনো? ছেড়ে দাও। সো ইউজিটি আগের দিন যেটা পড়িয়েছি, it is a three-terminal device, emitter and two base. Its IV characteristic is like this. So up to this, emitter voltage less than this, it remains off. A high voltage can be applied across this, but current the device allows to flow through it. is nominal. There is some reverse current. So switch is off. This is the off state. And once it exceeds this value, then it automatically, through a regenerative process, it immediately switches to this point, where the minimum voltage appears across this is very small, device very small VV, corresponding current IV, and now for further increase in applied voltage, the emitter circuit current will increase fast, but the voltage drop appears across the device remains controlled, very small. So in this region 3, the UJT offers nominal resistance. Its dynamic resistance is small, it is almost vertical. So switch is on here in the forward conducting region, and forward non-conducting region it is off. And obviously for reverse non-conducting region it is again off. So the switch specialty is it offers a non-conducting region under forward bias, unlike conventional PN junction diode, and it has a certain negative resistance region. This region appears due to this negative resistance region in case of UJT appears due to regenerative conductivity modulation. The phenomenon responsible for this negative resistance region is regenerative conductivity modulation. Now application, as it has some negative resistance region, so we can use it as switch because it has two distinct on and off switch separated by a negative resistance region. So application of UJT is for switching, for pulse generator and a sawtooth generator. Now we'll discuss UJT as a relaxation oscillator, UJT as a non-sinusoidal waveform generator, non-sinusoidal oscillator. For this, we make this circuit. This circuit should be always there for operation of the UJT. A VBB supply applied across the two bays, B1, B2. Now, a capacitor is connected between emitter and B1, and between B2 and emitter, a resistor R properly chosen is connected. Now, say we assume that there is small resistance, very small resistance connected to B1 and ground, যেটা UJT-তে directly করা ছিল. B1 was directly connected to ground, the negative terminal of the power supply. But here, if we connect a small resistance here, now what we see, if initially the UJT is in non-conducting mode, forward non-conducting mode, then we did not apply any source in this region. For oscillator, we never apply a source. For amplification, we apply a small signal at the input, it is our input, and we get an amplified version, larger version of the input signal, that is amplification. But for oscillation, we never connect any signal to the input. We generate an output waveform, but do not apply any input in this thing. So we get this out of nothing. No, we are also connecting some DC source in the circuit. Now, circuit requires some DC source. That means this DC energy will be expended, and at the expense of this DC source, we will get some AC power. So the DC power is converted to AC in oscillator. Now, this circuit is complete and we on this power supply. Now, it is under off condition because at V there is 0 voltage. Now, as soon as we on this power supply, switch on this power supply, this capacitor starts charging towards this voltage VBB. and its charging time constant will be RC. It charges through this R to this voltage VB. So this emitter potential here, VE, which we can also call here VC, the voltage across the capacitor, that varies, increases with time depending on this shear time constant. Then this V increases, and once this V achieves the value VP, for this UJT there is certain eta and VB we have applied. So accordingly, eta VBB will be the switching potential for the UJT, this one. So once this VC becomes VP plus V gamma, that is implied, but I am not mentioning it always. So once this gets this value VP, the UJT will be on. So a large current will pass through this and it will offer a very small resistance. So this capacitance, charge stored in the capacitance, will quickly be discharged through this circuit. UJT under on condition will offer small resistance, and we have chosen this resistance as very small. So it will quickly discharge this to this one. So discharge time constant will be will depend on C R dash R prime. Oh, এটা B1, তাহলে এটা আর নয়, এটা আর একটা কিছু করা উচিত ছিল, সরি, because this is our R, আমি এটাকে R prime ভাবছিলাম। আচ্ছা, তোমাদের অলরেডি নোট দিয়ে দিয়েছি। So take it must be some, say, make it a smaller. So the time constant will be CR. So this is the discharging profile. So discharging profile, it will discharge faster than charging. So once it discharges, so it is the capacitor voltage reduces to 0. Then again the UJT will be off because V has been reduced to 0. Then a fresh charging cycle starts. So thus we will get this type of periodic waveform. So we get a non-sinusoidal wave function generator, wave function generator here. Is it clear? Now we see that if we take a terminal, external terminal from this point B1, and we will see that the resistance across this R is and there will be a short pulse across this. During this discharge time, current will flow through this one. So there will be a narrow pulse corresponding to this discharging time. So we will get short pulse from this one. So UJT can be used as a pulse generator. Bolo.
ম্যাম ওটা y axis এ সেকেন্ড গ্রাফটা না y axis এ ওটা VR হবে না VR ড্যাশ হবে?
হ্যাঁ, এইটা ড্যাশ নয়, আমি এটাকে আর ড্যাশ,
মানে ওই যা ওই রেজিস্ট্যান্সটা তো,
হ্যাঁ এই রেজিস্ট্যান্সটা, এটা যেহেতু ক্যাপিটাল আর করেছি, এটাকে আদার দ্যান আর এনিথিং, এটা আসলে B1, কিন্তু আমি আসলে ভেবেছি আর ড্যাশ, সেই জন্য কিছু করিনি। এটাকে যে কোনো রেজিস্ট্যান্স অ্যাক্রস দিস করো, তাহলে এখানেও ভিআরটা তাই করবে। সো a pulse generator can also be obtained from this. Now we are interested in forming this one, sawtooth generator, used in time base for the oscilloscope. So this is the basic operation, charging, discharging, that cycle will be repeated. Now we want that this region is linear. That means we will choose this R as a very high one, so that time constant here is very high. It slowly discharges. So that means this portion will be too long, so that the portion of it up to this VP can be approximated at straight line. So to approximate this charging profile, part of this can be considered as a straight line. So to make this long, we choose a high R. So this is approximated as linear one, and we will remove this additional resistance from V1. There will be no resistance. So capacitance, we will assume that the capacitance discharges instantaneously and discharges to 0 voltage. So we will approximate this one as a vertical one. And the generated waveform can be approximated as such sawtooth type. Is it clear?
ম্যাম বলছি যে আরেকবার চেক করে নেবেন, অনেকে না বলছে ট্রাই করছে ঢোকার জন্য।
দশটা 22 সে কি মাত্র এই কয়জন স্টুডেন্ট? 51 তো কত 86 না কত? কি করবে, এই যে পরীক্ষা হবে, যে যা করবে বাস জাস্ট কপি করার টাইম।
ম্যাম
হুম
ম্যাম আরেকবার তো শব্দটা একটু বুঝিয়ে দেবেন।
হুম নিশ্চয়ই। এইটাতে তো কোনো সন্দেহ নেই, alternate charging discharging of the capacitor. So we get this one, but we want this one. We will convert it this waveform to this one. So this discharge should be vertical, abrupt discharge, and discharge is up to 0 voltage. So for this, it means our resistance discharging time constant should be as small as possible. So we will definitely remove this additional resistance R from the base circuit. And to this, for this linearly varying voltage during charging cycle, we should approximate this charging profile to be linear. That means we will make it too large so that a small portion of this falls within this region, 0 to Vp, and we can approximate it as a straight line. So we will make this resistance too high. A too high resistance is chosen here. That will increase charging time constant too large. So we will get this charging profile as a straight line, and we will remove this resistance so that capacitance discharges only through the UJT, which is now under on condition, and we will offer almost negligible resistance. So we can assume this to be vertical, and we get this type of waveform. Now we can determine the frequency of the generated waveform easily, because here we see that this charging one is the entire period. This is the T, because this is vertical. এখানে যেমন T on plus T off দুটো ছিল charging discharging এ. Now the discharging period is 0. So this is the entire time period. T is from this one. Now the capacitance voltage Vc T, which is our emitter potential, is the VBB, the supply voltage, into 1 minus e to the power minus TCR, the time constant. This one, VBB into 1 minus exponential minus T by CR. This is our capacitor voltage or emitter voltage. Now from here we see that when this capacitor voltage reaches this point value Vp, it discharges. So at T is equal to capital T, the period, our Vc or Ve is Vp. So we use this condition here, at T is equal to T, V is Vp. So we will write here Vp, and it is VBB into 1 minus e to the power minus capital T by Cr. So Vp by Vb. So we write Vp, take VBB that side. So Vp by VBB, which is nothing but eta, is 1 minus e to the power minus t by cr. মানে এখান থেকে আমরা কি হবে, তার মানে e to the power t by cr will be log of e to the power t by cr will be 1 by 1 minus eta. So t will come out as cr log of 1 by 1 minus eta. Now eta is fixed once we choose a particular UJT, but we can vary this one, both c and r, to vary this t, and frequency is just 1 by t. So the frequency of this sort of generator can be easily varied, and we normally vary this resistance. So it will then, if we add some potentiometer pot to in this region, we may use a pot, or we may add an pot into this R in addition to some pot, which will enable us to vary this resistance. So we can generate a sawtooth waveform of time period having some pre-chosen value. লেখাই আছে, পড়লে বুঝতে পারবে। আমি আপাতত যা ডিসকাস করলাম, ইজ ইট ক্লিয়ার টু অল?
ম্যাম এটা কি UJT এর এফিসিয়েন্সি?
এটা না, না, ওটা ওর একটা ক্যারেক্টারিস্টিক ফিচার যেটা ডিটারমিন করছে যে ভিপি কত হবে। সেই বুঝে আমরা যা এক্সটার্নাল ভোল্টেজ লাগাবো, এটা ভিবিবি উইল বি দ্য সুইচিং পোটেনশিয়াল। So eta is fixed for a particular UJT, so we will vary this supply voltage to vary the switching potential. ওটাও একটা প্রপার্টি, মানে ম্যানুফ্যাকচারিং এর সময় ডিপেন্ডিং অন দ্য লোকেশন অফ দ্য জাংশন, কিন্তু এটা এফিশিয়েন্সি।
আচ্ছা ঠিক আছে।
So UJT is over, কারো কিছু জিজ্ঞেস করেননি, আমি তো বেরিয়ে যাচ্ছি। SCR এর প্রবলেম হচ্ছে আমি নোট করে পাচ্ছি না, সিম্পলি রোজ ক্লাস SCR আমি তোমাদের এমনি পড়াবো, সেই জন্য আমি বললাম চাও তো একটু ইয়ে করে নিও, আজকে একটু নোট করো। আমি জানি না এই আমার এই ট্রাফিক কোডের ফাইল কি করে ট্রান্সফার করবো, সেটা আমি জানি না, কোনো কাজ করে উঠতে পারছি না, একটু ডিভোট করবো রোজ ক্লাস ঘন্টার। No. So basic, the most important power device is silicon control rectifier. Semiconductor control rectifier is the denial name, but we invariably use silicon semiconductor, so its alternate name is silicon control rectifier. The name implies control rectifier. That means it is mostly used for controlled rectification. Rectification from conversion from AC to DC. Now, control rectification means we will control the rectification process. That means the DC converted from the AC can be varied. Controlled amount of DC will be generated from a given AC. So the name silicon control rectifier. But before this, to explain how SCR is used, we should first discuss the working principle of a basic diode. And once it is clear, silicon control rectifier is just a small modification made over this structure. So first we should concentrate on the fundamental device. PNPN diode means it is also called 4-layer diode or Shockley diode. It was discovered in 1950. So, যে কোন স্ট্যান্ডার্ড বইয়ে পাবে টোটাল জিনিসটা, চিত্তন ব্যানার্জিতে তো আছে। So, if you want, you can note it, but I have no ready material to provide. So, it is 4-layer. There are PNPN, 4-layer in the device. But still it is diode because it has only two terminal, two electrode. So it is a diode. It has three junctions. We see that in case of UJT, it is a single junction, but it is a transistor. Similarly, these are called also in the special category of device. They have three junctions, but still these behave as a diode. We cannot control its property. No controlling terminal is there. In case of bolo,
বলছি একটা ভোল্টেজে মাল্টিপল কারেন্টের সিগনিফিকেন্সটা কি ফিজিক্যালি?
একটা ভোল্টেজে মাল্টিপল কারেন্ট, আচ্ছা এরকম কিছু, দ্যাট
হ্যাঁ।
ইজ সুইচিং। সেটাই তোমার হবে। এই যে এই ভোল্টেজটা ফিজিক্যাল সিগনিফিকেন্স কি বলি বলো তো?
মানে এই ভোল্টে মানে এই কারেন্টটা কি বিভিন্ন সেকশন হবে মানে
না,
ডায়োডটা?
এটা ডিপেন্ড করবে এই যে ভিভিও ভোল্টেজটা তুমি কোন ডিরেকশনে যাচ্ছ। If you attain this voltage, when you are increasing the voltage, it will be in off state. So এইখানে কিন্তু তুমি যদি এখান থেকে এটা এই অনে চলে গেছে, now if you decrease this voltage, this region will not be repeated. It will not follow this path. It will directly come to this point. This portion will not be repeated. Path during off to on and on to off of the switch are not same. Let me explain its working, that will get clear now. So PN 4 layer, two terminal, one is called anode and other is called cathode. So we normally you assume we write it as VAK, voltage difference, potential difference applied across these two terminals. So cathode যদি C লিখি, in that case it appears as VAC, and that may confuse us that it is a AC voltage. So it should be, cathode should be C, but we write it as K, so that we can say that we vary the voltage VAK. আমি কন্ট্রোভার্সি এড়ানোর জন্য সিম্পলি V দিয়েছি, বাট it is basically V subscript A. So anode and cathode, two terminal, 4 layers, so 3 junction, A1, A2, J3, 3 PN junctions are there. And say I is the current flowing through the device, entering from anode to and coming out to cathode, and we will consider this current as positive when it enters to the anode. So we plot I and V, and this is the characteristic of the device. So first, see the characteristic. There are this region up to this. VBO is the breakover voltage. The voltage, যেমন UJT-র VP বলেছি, just this. So when the applied voltage exceeds this voltage, breakover voltage, the device switches to on condition, this point, where it is the valley voltage, minimum voltage, and the corresponding current is IV, valley current. And it increases from this. For further increase in voltage, it will follow this one, where the dynamic resistance of this region will be very small. Voltage across the device will be very small, but current flowing through the device is large. So this is the off state of the switch. This is the on state of the switch. They are separated by a negative resistance region. Again, this transition will take place so fast that we can never measure any value within this range. No point can be obtained. So once it exceeds this breakover voltage, it will directly comes to this point. Now, this VV, IV cannot, because once it is on, its minimum voltage must be maintained this. If we reduce with the applied voltage, then PV is the valley voltage of valley নয় তো, it is holding voltage. তাহলে কোথায় লিখলাম? তাহলে সিআর লিখেছি, সরি In case of SCR, it is holding voltage. The minimum voltage that holds the on state of the switch, and corresponding current is holding current. That means for on condition, switch will be on when current is greater than is equal to holding current, and voltage is greater than is equal to holding voltage. So they are called holding voltage. It holds the on state. When it is reduced beyond this one, the device will attain the off condition. It will move from this region. Okay, first let me explain its characteristic. So this region, for region 1, this is positive, this is negative. So our J1 and J3 junctions are forward bias. সনিল ক্লাস নিচ্ছিলাম, ক্লাসের পর বলি খুব আর্জেন্ট কিছু। ও আমি খবর নিয়েছি, রিপোর্ট গত সপ্তাহ খবর নিয়েছি, তোমার থিসিস এর রিপোর্ট একটা এখনো পেন্ডিং, আর ওইটা এসে গেছে। হ্যাঁ, আমি আগে শুক্রবার গেছিলাম, তো আমি খবর নিয়েছি। তো এবং উনি সিকেএস এর খুবই পরিচিত, সিকেএস কে যদি একটু বলতে পারো যে একটা রিমাইন্ডার, ওনারা বলেছেন আর 1 মাস বাদে রিমাইন্ডার দেবেন। তো আমি তো ওদের ফোর্স করতে পারি না, এবার সিকেএস এর পার্সোনালি উনি খুব ক্লোজ, আমি নামটা যা শুনলাম, তোমাকে আমি ডিসক্লোজ করবো না সেটা, কিন্তু সিকেএস কে বলো এটা, উনি একবার ফোন করলে দিয়ে দেবেন, অনেকদিন হয়েছে, এবার দিয়ে দিন। হ্যাঁ, তাহলে ওয়েট করো, ওনারা বলেছেন 1 মাস দেখে রিমাইন্ডার দেবেন, তাহলে 1 মাস বাদে আবার আমাকে একবার তুমি বরঞ্চ মনে করে দিও, আমি গিয়ে আবার একটু ওনাদের বলবো। গত শুক্রবার আমাকে বলেছেন 1 মাস, মানে ধরে নাও এন্ড অফ ফেব্রুয়ারি, তাহলে আমি এপ্রিলের শুরুতে তুমি আমাকে একটা কল করবে, আমি গিয়ে ওনাদের বলবো যে এইবার রিমাইন্ডার। সিকেএস এর একটু বন্ধু, সিকেএস না বললে আমি বলতে পারি না। ঠিক আছে, রাখি। হ্যাঁ, তুমি প্রেজেন্টেশন রেডি রাখো, তোমার তো প্রি সাবমিশনটা হয়েই আছে রেডি। হ্যাঁ, ঠিক আছে। আচ্ছা। So in this region 1, J1, J3 forward biased, J2 junction reverse biased. In this region 2, আচ্ছা আমি এখানে একটু লিখিনি। This region 1, J1, J3 forward biased, J2 reverse biased, and this region is called forward blocking region or forward non-conducting region. It is forward biased device, but it does not conduct. So forward non-conducting region. Then region 2 is the negative resistance region, and here this negative resistance appears due to regenerative transistor action. UGT তে এটা conductivity modulation ছিল, but here it is regenerative transistor action. Region 2, negative resistance region. In region 3, all the 3 junction gets forward biased. That means now the device will offer nominal resistance. All 3 junctions are forward biased, so it is now capable of carrying a large current, and resistance is nominal, so it is forward conducting region. যেমন ট্রানজিস্টরের যেমন স্যাচুরেশন রিজিয়ন, লার্জ কারেন্ট, স্মল রেজিস্ট্যান্স। So 3 is forward conducting region. Now when the polarity of this voltage is reversed, then the current will flow in the opposite direction, but no, its magnitude is nominal. So region 4, this side positive, this side negative. That means now the middle J2 junction is forward biased, but J1, J3 are reverse biased for this 4 and 5 both. And it is forward, it is reverse non-conducting region or reverse blocking region. And that reverse region 5 is the breakdown region, when the junction is J1, J3 reverse bias. So when breakdown occurs at any of these reverse bias junction due to large applied reverse bias, breakdown will occur. But when we get this type of negative resistance region and the blocking and conducting region under forward bias, we utilize this region because this region that is no control. This is almost similar to any conventional pin junction diagram. Yes, magnitude may be different, large, but characteristic is like a conventional diagram. So for such special devices, we are interested in this first quadrant, forward bias. When we will get a blocking region, off state and on state, and also a negative resistance region separating the off and on state of the switch. So this is the region of our interest and we will explain this. Now how we get this? We call that the negative resistance region appears due to regenerative transistor action. আজকে একটু রেকর্ড করলে হতো যেহেতু ইয়ে দিচ্ছি না মেটেরিয়াল দিচ্ছি না we see that first this region 1. As forward voltage V is increased, we see that J1, J3 gets forward biased. So resistance will be nominal, depletion region will be narrow, and they are able to carry large current. But the middle junction is reverse bias. So basically the net current that can flow through this its magnitude will be dictated by this one. The current that this junction can support. তাই না? করবো আমি এখনো বলিনি কিছু এটা তো ডেফিনেটলি এই যদি আমার একটা জলের পাইপ হয় লাইক দিস middle একটা constriction আছে so whatever be the cross section of this terminal region ultimate water flow will be controlled by this one. It is just like this. Two terminal forward bias junctions are able to carry large current, offers nominal resistance, but they are separated by a reverse bias junction. So net current flowing through this will also be very nominal. Now, what is the minimum current that flows through this? Basically, regenerative transistor action. এটা কিন্তু সত্যি complicated. মন দিয়ে বোঝার চেষ্টা কর। আচ্ছা আমি আগে ম্যাথমেটিক্যাল এক্সপ্রেশনটা করে নিই তারপর ফিজিক্যালটাই দেই। So this is our junction device, 4-layer diode. We cut the device. We imagine that the device is cut like this from this corner to this corner, and the two region is mechanically separated but electrically connected. That means we consider the device like this. They are shifted, separated, but they are electrically connected. P region is shorted to P, N region is shorted to N. Now we can imagine the structure as two transistors, PNP and NPN, where it is the emitter of the PNP transistor. Why? It can also be emitter, but we assume them as emitter because this side it gets positive voltage. So this junction is forward bias, so we choose it as the emitter. And similarly for this one, cathode is এটা রিভার্সের সময় বলেছি cathode pole is negative, so our NP junction will be forward bias. So we also assume the cathode terminal as the emitter of the NPN transistor. this is the current I, and it is positive. So we get that we can imagine the structure as combination of two PNP and NPN transistor, where base of PNP transistor is connected to collector of NPN transistor. A PNP transistor, it is transistor 1, PNP, and NPN is 2. So we write this is the symbol of PNP transistor, anode is the emitter, positive sign, current enters through this anode. So this is emitter. Now its PNP transistor, its base is N, which is shorted to collector of NPN transistor. So base, N-type base is connected to collector of the transistor 2, NPN transistor. And it is the emitter because it gets forward bias. So cathode is the emitter. So I current, this I current flows through I current comes out of the device through this emitter of the NPN transistor. Again, two P regions are shorted, means collector of transistor 1, PNP transistor, is shorted to base of NPN transistor. So this one. So we can draw this circuit equivalent to this structure. So we see that it is for PNP transistor, emitter current enters through this. So say it, then it is IE1, and this is base current IB1, IC1. So IE1 is IC1 plus IB1 for transistor 1. Now this IB1 is basically the collector current of transistor 2. So we simply write IC2 in place of IB1. So we see that IE1 is IC1 plus IC2. Now IC1, we can write IC1 as alpha 1 IE1 plus ICBO1. IE1 is the emitter current entering the PNP transistor. Alpha 1 is its common base control current gain. And similarly, this is alpha 2 IE2 for transistor 2. But this one, ICB1, that is the thermally generated current component flowing across the reverse bias collector base junction for transistor 1, and it is ICBO2 is for transistor 2. So we can write IC1 plus IC2 like this. Now we know that this IE1 is equal to IE2, and that is our device current I. So we write I here. I is alpha 1 plus alpha 2I plus ICB1 plus ICBO2. So we can find an expression I as ICB1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. It is for region 1. We are considering the region 1. So we see that when alpha 1 plus alpha 2 is very small, nearly 0, the current flowing through the device is sum of the two reverse saturation current. So it is basically very nominal current. Leakage current in absence of input 1. So this is very small, of the order of ICBO, but it flows in the forward direction from this to this along the direction of I. So we draw it in the first quadrant. It is positive. Its magnitude is very small, but it is positive. So this explains the region 1, and device is now off because it's off. large voltage can appear across it, and it will allow only a nominal current, leakage current flowing through this. But this approximation is not, this approximation is not correct, because
ম্যাম
from
একটু এখানে দাঁড়াবেন ম্যাম,
হ্যাঁ,
একটু এখানে দাঁড়াতে আমি একটা জাস্ট কপি করে নেব একটু।
ও আচ্ছা আচ্ছা, আগের পেজ না এটাই?
না ম্যাম এটাই ঠিক আছে, হয়ে গেছে।
এইটা আসে কেন?
হয়ে গেছে ম্যাম, হয়ে গেছে।
হ্যাঁ, আমাকে তো দিতেই হবে। কোথায় গেল মেটেরিয়ালটা? তো কিছু ঘটে না। ওপো এটা দেখাচ্ছে না। So from this expression we see that this is the current flowing through this device.
ম্যাম আপনার স্ক্রিন প্রেজেন্ট করা নেই।
সেটা আবার কখন চেঞ্জ হলো? কখন তো আমি স্টক প্রেজেন্টিং করেছি। ঠিক আছে,
ইয়েস ম্যাম,
দেখতে পাচ্ছ তো? হ্যাঁ। So we see that if alpha 1 plus alpha 2 is very small, nearly zero, this is the net current. And when alpha 1 plus alpha 2 tends to 1, current will be very large. তার মানে আমরা বলছি alpha 1 and alpha 2 will vary, and it is true, it will vary for this device. কেন সেটা পরে বলছি। So this, when alpha 1 plus alpha 2 approaches the value 1, current will be large. A large current will pass through the device. That means it will switch from region 1 to region 3 due to this regenerative transistor action. So when alpha 1 plus alpha 2 becomes close to 1, becomes 1, then this regenerative process will be initiated, and it will drive the device to saturation region, that forward conducting region. Now, what is the regenerative transistor action? We see that some current enters the device, then it has some IB1 and IC1. Now, this IB1 is beta times multiplied to give this IC1. Now, this IC1 is this current of transistor 2. So, its collector current IC2 will be beta 2 times IB2, beta 2 times larger, and that forms the base current of this one. So again, this base current will be beta 1 times multiplied to form the IC1, and which in turn will be beta 2 times multiplied to gives the IC2, which is nothing but IB1. So basically, this current, this is the regenerative transistor action, and thus current will start increasing, and very fast it will achieve this. The current will be very large, and our expression will be correct. Now, this relation, তার মানে কি আমার I should be infinitely large, but we see that it basically is a small one. It is not very large, but it comes out of this region 1 due to this regenerative transistor action. It is now not too high, since this equation we write that is true for active region of the transistor. But once the transistor enters in the saturation region, this equation is not valid. So due to this regenerative transistor action, our transistor comes out of active region to here. Since all the junctions are forward biased here, that means if we assume that structure as combination of two transistors, both transistors are now in saturation region, and only then the input device can offer a nominal resistance and can allow a large current through this. So this is all related to this approximate expression. This is just an approximate expression for current in the valid in this region 1, because neither of the structure behaves as a true transistor. And we are considering alpha 1, alpha 2 variables. Now what happens practically? You see that now concentrate. This PN junction, middle one is reverse biased. Middle one is reverse biased, upper forward biased. So I assume that the depletion region appears only, highly resistive region appears only in the middle of the junction. And I will ignore depletion regions for the two forward bias junction J1, J2. Now, as we increase the voltage, we assume that the applied voltage appears across this highly resistive region. That means reverse bias junction J2. All these are neutral region and forward bias junction. So this voltage appears across this. Now, as we increase this forward applied bias, the reverse depletion region extends on either side. That means the neutral base region of the two transistor decreases. আচ্ছা ওটা বলারও আগে ইনিশিয়ালি আমি বলি why we get this IC0 for small applied voltage. You see that this junction is reverse biased and these two forward biased. So what is the steady current flowing through the transistor? Flowing through this PNP diode due to this forward bias. We see that PN junction is forward bias, so holes will be injected into the N-type base, and these injected carriers will reach the depletion region of this junction and will be drifted. Now, this steady jump, this flow of holes will be maintained as this injected holes from emitter enters the N region. They will recombine with electron. Similarly, injected electron from this will recombine with hole in this region. But these electrons or holes are not resupplied because there is no connection from the collector base junction. This junction is the collector base junction for both transistors. So this collector base reverse bias is absent here. That means there is no base bias here. So only emitter gets this bias. That means the compensation of the lost electron and hole from these two junctions are absent. So what will happen? For further increase in as more and more holes are injected here, electrons are lost, and gradually the negatively charged space charge will be positively charged donors here and negatively charged acceptors will be exposed in this region. So positively charged donor will make it positive. So effective forward bias of this junction will gradually reduce. And eventually the injection will stop, even if we apply some positive voltage here. Same is true from this end. Electrons are being injected, holes are lost, and negatively charged accepted ions will make this layer negative gradually. So the forward biasing of NP junction will be reduced, injection level will reduce, and so gradually more and more electron injection will make it more and more negatively charged. So finally the injection will stop. So no injection from these two terminal forward bias junction will take place unless and until the lost carriers from the neutral base are supplied to maintain the charge neutrality of the base region. Is it clear? Now, there is then how this IC zero flows. We should get zero current. But see that this middle junction, PN junction is reverse biased. Middle NP junction, G2 is reverse biased. That means thermally generated electrons in this depletion region and within the P region, the diffusion length of electrons adjacent to this depletion region edge will be swept by the junction field and may appear here. Similarly, within this length LT, minority carrier diffusion length in N region, these thermally generated holes in this region will be able to reach to this P region. So that is a only source that compensating the loss of the electron and holes. So these thermally generated electrons is the steady supply for the particular P, and that is the thermally generated holes is a steady supply for this P region, P-type base. So only this weak flow of electron and hole, thermally generated electron hole, compensate the loss of electron and hole here, hole and electron here. So the steady compensation will allow injection from these two forward bias terminal layers only by that amount. এই অ্যামাউন্টে আমি কম্পেনসেট করছি, ইনজেকশন লেভেল উইল অলসো বি অফ দ্যাট অ্যামাউন্ট ফর স্টেডি স্টেট। সো উই গেট কারেন্ট that is forward current only of the order of leakage current thermally generated and due to thermally generated minority carriers for this device. So we get region 1 forward current of the order of ICBO in general. Clear? Then I will move to next step. কোনো confusion নেই তো? Then I will assume it clear. Next process. So we get this current. Only this condition is there. From this expression, we see that alpha 1, alpha 2 is very nominal and it is roughly 0. So our net current is of the order of ICBO. Now, we are increasing this. Initially, this is the ICBO. Now, and this current should be independent of voltage. But now, as we increase the supply voltage across this VAK, then this depletion region becoming broader, wider. That means the neutral base, width of neutral base is getting reduced. So the injected holes here, it may be very small, but this injected holes will normally injected hole will be recombined here and they cannot reach in this junction. Similarly for holes. So the transistor action is not coupled. Here two transistors are isolated. And only each of this case, only injection level is determined by the generation rate of electron hole pair, thermal generation rate of electron hole pair. Now, as V increases, the base of both transistors are getting narrower. Now, the same level of injection of the order of ICBO, same level of injection is maintained. Injected holes now will be recombined here, but now they are facing narrower base. So probability that they will pass through this base and will reach the other side is gradually being increased. Base narrowing effect makes this due to early effect, base narrowing effect. Same level of injection is there, but their base transport factor is gradually increasing. And thus, both alpha 1 and alpha 2 are also gradually increasing for both transistors. So since here the structure lacks collector base reverse bias, our gain alpha 1, alpha 2 increases gradually. And finally, when alpha 1 plus alpha 2, sum of these two tends to 1, then the switching will occur. In our normal transistor, each of these alpha 1 and alpha 2, individual alpha 1, alpha 2 are close to 1. But in this case, they are very small and sum of them will be 1 when switching will take place. So we see that here alpha 1 and alpha 2 gradually increases for these structures. Now when occurs that the base transport factor gradually improves and base neutral base is gradually getting narrower. So it may happen that the same level of injection, the injected holes will recombine here, but base is so narrow that they may survive. Significant fraction of this injected hole may survive, may diffuse to the neutral base and reaches here. And they will be swept by this junction field and reaches here. That means these injected holes now compensate the loss of hole here. Similarly, the injected electrons may survive through while traversing this narrow base and may appear here. And then it will compensate the loss of electron here, at least a very small amount, but that is another also be compensated in addition to the primary generated component. That is always there. So the now compensation amount is larger, so that will increase the injection level on either side. So greater amount of holes will be injected. So the greater amount of, if we consider the same fraction, then greater amount of hole will appear here, compensate loss of hole, will invite stronger injection of electron, and they will also be able to appear here, and stronger compensation appears. So again, next time the whole injection from this emitter will be even stronger. Thus, the regenerative transistor action will take place. And finally, we will see that this both of the transistor as if moves to saturation region. As soon as electrons are injected holes appear here, then strong injection of electron and strong injection of hole appears due to this coupled transistor action, and these holes, large number of holes appear here, that will make these uncompensated ionized acceptors neutral. Similarly, injected electrons will appear here, neutralize the greater part of the ionized donors positive charge. So this depletion, middle depletion region will also be narrow and the junction will get forward biased. So all the three junctions are then forward biased and this device attains this state, this one. So this switching appears due to regenerative transistor action, the coupled transistor action, and that happens due to base narrowing effect. আরো একটা effect আমাকে বলতে হবে, কিন্তু first see that whether it is clear or not. ঠিক আছে? না বলবো আবার? should I repeat or is it clear? কিছু বলো, মুখ তো দেখতে পাই না, ওই জন্য এখন প্রবলেম। Clear?
Yeah, ma'am.
Okay. Then I explain the switching from 1 to state 3 due to this narrowing effect only. And the underlying mechanism is the physical mechanism is coupled transistor action. So injection level of from one transistor, once it increase, it will invite the stronger injection from the other end also. And stronger injection from this will make this injection from this transistor one even stronger. So this coupled transistor action finally drives the all the junctions forward will be forward biased and it will be driven into this region, forward conducting region. Now, if we consider the another effect separately, that we are not considering this narrowing. Now, what will happen if we increase the voltage continuously? This region, depletion region, is continuously increasing, expanding, because entire voltage appears across the reverse bias. Now, at for particular field, at too high voltage, now avalanche multiplication, avalanche breakdown may take place here. That is very logical. So once avalanche breakdown appears, say at this voltage VDO, breakover voltage, then large number of electron hole pair will be generated due to the avalanche multiplication, and those generated electrons will be negative. So direction of field is this one, positively charged donor to negatively charged acceptors. So this is the junction field. So as applied voltage increases, junction field increases, and finally avalanche breakdown takes place in this reverse biased PN junction. Large number of electron and hole will be generated. These generated electrons in this region, depletion region, will be drifted by this junction field in this direction, and the holes will be swept in the direction of the field. That means those large electrons will appear in this N region and holes in the P region. So these injected large number of electrons now will compensate the loss of electrons from this N-type disk and also compensate this part of this space charge. And similarly, large holes will compensate the loss of holes and it will be compensate this one. So it will make the T2 junction forward biased. And again, we can say that once this electron compensation here, loss of electron is being compensated, then their injection level will readily be stronger. So now the strong injection of hole will take place. These injected holes now will be able to, because now injection level is quite high, the part of them will be lost here, but a major portion of these injected holes will appear here. And they will, and the part of electron injected in here will circulate and will appear here. Now, these injected electrons will compensate the loss of electrons here, and injected holes from this end will compensate the loss of holes here. So the injection from both ends will now, henceforth, they will compensate the loss of carriers in the base region and will maintain the steady injection. So once this breakdown occurs, this initial deficits are compensated by the generated electron hole, then these injected areas from either side of the junction will maintain the supply, the compensation of carriers on the two base region. So এই ব্রেকডাউনটা হলো we need not this should not is not required to maintain this continuous one. Initially একবার যদি breakdown হওয়ার জন্য initial deficit is compensated, then these two transistor injection from two emitters will in turn compensate the loss of carriers in the base region and will maintain the carrier injection and the device will be base region.
ম্যাম
Follow.
ওই কেরিয়ার যে কম্পেনসেট করা পার্টটাকে আরেকবার একটু বুঝিয়ে দিতে পারবেন?
নিশ্চয় ব্রেকডাউন হলো সেটা অ্যাডমিট করলে অ্যাভালাঞ্চ ব্রেকডাউন সো ইনিশিয়ালি as soon as breakdown occurs large number of electron hole pairs are generated. Now this is the direction of junction field because it is reverse biased, right? So under this field electron and hole pairs are generated within this depletion region. So electrons will move swift in the opposite direction. So generated large number of electrons will appear in the n-type base, and the holes drifted along the direction of field will appear in the p-type base. Now, this large number of electron here will compensate the loss of all electrons in the base so far, and holes, the deficit of holes here, and the space charge on this middle junction, reverse bias junction region will also be compensated partly. So depletion region will also be thin, and that means that the junction is forward bias. You can also think it like that. Large number of holes is there, so this region is positive. Presence of large number of electrons in this region will make this layer negative. So our middle junction is now forward bias. So all three junctions are forward bias, but I am not interested in that. All three junction forward bias, so the dynamic risk is small, large current can flow now. But main thing is this due to breakdown, the supply of large number of electron and hole takes place on because once they generated, they make the middle junction forward bias. So no more breakdown will take place. So no more supply of electron and hole. So initially at one stage, one time you will get the large number of electron and hole here. So these electrons compensate the loss of electrons from the n-type base. So it will make the base region neutral, and then immediately the hole injection will be greater, higher in that position. So larger number of hole will be injected, and these holes, since the injection is quite high, the significant fraction of this injected hole now will survive while traveling through the base and will appear in this p region. So now this p region already its initial deficit is met by the avalanche breakdown, and that makes this injection of electron from emitter quite strong. And these electrons also, significant portion of electron will be able to appear here. So now this electron injection, this presence of this additional electron will make these injections of holes stronger, and presence of additional holes here will make the electron injection stronger. So thus the coupled transistor action drives the device into this region on state. Because this we are not maintaining this breakdown, we are not relying the breakdown forever. One time, once the breakdown appears, this junction is forward bias, the deficits are met, then these two transistors, their coupling, through their coupling action, will supply the required base region for the other. Their one transistor will make the supply of the carrier in the base region of the second transistor. তাহলে দুটো ইন্ডিভিজুয়াল mechanism আমি বললাম so that the diode can move from off to on condition. One is through base narrowing effect, so that base transport factor base are being gradually thin, narrow, neutral base. So base transport factor gradually improves, and finally alpha 1 plus alpha 2 summation becomes 1. It makes the drives the switch device into on condition. So practically combination of this both base narrowing will be present and the avalanche multiple breakdown may also present. So this combination of these two, either of the one or combination of the two, will be responsible for switching of the device. I mean, just point to লিখেছি applied voltage between 0 and VB oblique over voltage, and voltage increases width of the reverse bias junction, depletion width increases, so B1, B2 improves, that improves alpha 1 and alpha. Now when alpha 1 plus alpha 2 sum tends to 1 from this expression, the switch fires. Switch moves from off to on state. So large current device is now capable of carrying large current. So switch is now on from 1 to 3 state. And firing takes place through base narrowing effect or avalanche breakdown or both. Combination of both. Actually combination of both. So due to base narrowing will always be there. So for this, the depletion region is gradually increasing and neutral base is being narrowed. And the breakdown voltage will appear. This applied reverse bias will appear across this, and it will assist. Base narrowing effect will assist the avalanche breakdown to appear at a smaller reverse bias. দুজনের পারপাসটা সেম. So this is the operation of this PNP diode. This is the basic device. যদি এই জিনিসটা বুঝো তাহলে পরের ডিভাইস গুলো আর বেশি কিছু বলার নেই. এটাতে কোনো কনফিউশন নেই তো? And under reverse bias, this one. Under reverse bias, this is negative, this is positive. That means that the middle junction J2 is now forward bias to the on J3 reverse bias. এবার আমরা যত বাড়াচ্ছি ultimately at one point, since these terminal layers are reverse biased now, it is positive. So terminal layers are reverse biased. So we cannot assume them as two transistors because their base emitter junctions are now reverse biased. আর যদি বলো যে না এটা reverse bias, so this is our collector junction, then this junction will be their emitter junction, but there is no bias in the emitter junction. So the couple transistor action or their device cannot be assumed as two transistor when reverse bias, opposite polarity is applied here. Clear holo? For region 4. It is negative and it is positive. কাজেই এদের আর আমরা ট্রানজিস্টর হিসাবে ধরতে পারবো না. They reverse bias, these two junctions. So middle junction forward bias. So ultimately, if we go on increasing, the net current flowing through this device is now the nominal current, reverse saturation current, and it flows in the negative direction, positive to negative. So it is drawn the third quadrant, and finally for two large applied voltage, avalanche breakdown will appear in junction J1 and J3, depending on the doping level. If their doping levels are identical, then the reverse breakdown, avalanche breakdown will appear at the same voltage, otherwise that depends on doping level. তাহলে এটা ওভার ধরছে 11:30। Now we will consider the silicon control rectifier, which is nothing but that device PNPN layer. Oh, the structure টাই আঁকিনি। SCR is basically the diode PNPN layer. This is anode, positive করে দিই, and this is cathode. So difference of SCR is it is a 3-terminal device. There is control. The third terminal, control terminal, is called gate. So in absence of any bias voltage applied across gate, it will work simply as a 4-layer diode or Shockley diode, and this is the VDO, breakover voltage, depending on that structure, and it will swing from off to on condition. Now this third terminal provides some control. If we apply some positive voltage across this, say the applied reverse bias, we have applied the voltage, the VAK is such that it is here at that position, less than VDO. So this small current is flowing through this. Now at that position, at that point, if we apply a positive voltage to the gate, not a DC voltage, if we apply a positive pulse at the gate, a narrow pulse like this, a positive pulse, narrow pulse is very narrow pulse, we call them the triggering pulse, like spike. So its magnitude is this. If we apply this pulse, positive pulse, that means we are applying bunch of hole. We are introducing bunch of hole in this P layer through this gate terminal. Then this positive pulse, these holes will immediately compensate all loss of hole in this neutral, in this base region. So it will invite strong injection of electron from this cathode. And this now, since this large number of electrons, a part of them, significant part of them will reach this N region, will satisfy their demand of electron and invite fresh strong injection of hole here, so that now the significant portion of that hole will survive and appear here and will meet demand of hole here, and injection of electron is maintained. Thus, the coupling action of the two transistors is being initiated once we apply a positive pulse at the gate. Just introducing some holes here, supply of hole here, but mind it, we need not apply a DC voltage. We should, in case of SCR, that is the great advantage of SCR. আমার এই কন্টিনিউয়াস পজিটিভ বায়াস মেনটেন করার কোনো দরকার নেই। ট্রানজিস্টরে যেমন আমার বেসে কন্টিনিউয়াস সাপ্লাই দেওয়ার জন্য বেস ইজ অলওয়েজ বায়াসড, কিন্তু আমার গেট কিন্তু তা নয়। We will simply, a narrow pulse is sufficient to initiate the process. And once this deficit of hole of one base is satisfied, it will automatically invite large injection will be stronger. Here it will be loss will be compensated, holes will be stronger, and these injected areas on either side now will make the device sustain their requirement of hole and electron compensation will be satisfied by the injection from the other two media. Hello, Ramni? হ্যাঁ হ্যাঁ ক্লাস নিতে হাফ অ্যান আওয়ার বাদে 12টা বাজলে আচ্ছা so this is we call it just a triggering pulse. It will trigger the coupling action. Is it clear? Clear নয় আবার বলবো
Yes, you are so right. ম্যাম একবার বলে দেবো।
নিশ্চয়ই একবার বলো না না বুঝলে কে বোঝাবে এটা তো আমারই ডিউটি it is basically full layer diode. If normal breakover voltage is this one, so when the applied voltage exceeds this one, the device will automatically switch from off to on state. So that is the diode. But for this layer, we have taken a control terminal out from this layer, P layer adjacent to the cathode. We take this terminal and we use it as the control terminal. We will control the switching potential. That means the device will move from off to on. So we want to control this one. So the third terminal, control terminal, is called gate. And if we apply a gate positive pulse to this gate at any voltage, at any value of VK less than VBA, তার মানে ব্রেকওভার ভোল্টেজ এখনো অ্যাপিয়ার করেনি সো ইট ইজ normally it will remain in the off state. Now if at any point V less than 0 we supply a narrow pulse positive pulse at the gate terminal means we are introducing the month of hole in the P region. Now this large value of hole will compensate all deficit of this base region. And এর আগে আমার ইনজেকশন লেভেল তো উইক ছিল বিকজ there were uncompensated acceptor ion space charge and the only injection level was by the of the order of the thermal generated electron and whole rate of thermal rate generation rate of electron hole there. Now these holes induced holes will satisfy the demand of hole here, compensate all the negatively charged acceptor ions and things. So it will make the periodium neutral so that now the strong injection will take place. Starts here. Due to presence of this, the injection from this N region will be initiated. Now, so these injected electrons now will be recombined. Part will be recombined here because these regions are not clean as in case of a BJT. So part of them will be lost here, but a significant portion of this will also be able to appear in the same region. এখানে ধর আমি কোনো পালস দিচ্ছি না so these injected part of these injected electrons will satisfy the demand of electron here partly, then that will cause the injection of hole from this to increase to some extent. So these injected holes now injection electron to compensated হয়েছে ionized donors in n-type base. Now these injected holes will recombine here, but a significant portion will also be able to appear here. And so this flow of hole will invite more electron injection from this region. And these injected electrons will appear here and will make the injection of hole here. So thus the injected area from emitter of one transistor will satisfy the demand of carriers. Loss of carriers will be compensated in the base of the second transistor. And in the naturally it is true for this one. So once we just initiate this one, this deficit is satisfied, then this coupled transistor action will be generated. So they just initiate the process. Into once the coupled transistor action is initiated, this gate supply need not be there, present there. So we just introduce a narrow pulse to initiate this. It is not a continuous gate bias, is not required. Unlike in BJT, unlike in MOS, so it is simply a narrow pulse, like a spike. So thus applying this, it was said VAK was this one. So once it is introduced, applied, this resonant transistor action will be initiated and device will move to on condition. That means the switch is now on at a voltage less than VDO. So similarly, if the gate current we consider or gate voltage, whatever you want, you can call that. So we increase the pulse magnitude. Stronger the pulse means stronger the supply of the hole, smaller will be the voltage the device will be able to switch to on state. Switching will take place at a smaller applied voltage, smaller VAK, as the supply is stronger. So gate current if increases, then supply switching will take place at smaller voltage. In absence of gate current, it was VBO, the breakover voltage for the diode. In presence of this SCR, smaller, greater the gate supply of these carriers, means the magnitude of this triggering pulse, the switching will take, device will be able to switch at smaller voltage. ঠিক আছে? Now this gate current amplitude is only of the order of milliamp, a very small current, where it is a power switch. So it will handle kilovolt of power voltage and the current of the order of kiloamp. So large current and voltage, the switch will handle large current and voltage, but its operation can be controlled only by a very small current, milliampere. And that too, that we need not maintain that control voltage or current. It will just spike like pulse to initiate the process. Then the rest is done by the coupling action of the two transistors in the device. So that is the main advantage of silicon control rectifier. A very small current controls large current and voltage flowing to the device. Now on to off condition. The device is on. Now I want to drive the device into off state. So we will reduce the applied voltage, and once the applied voltage is reduced below this holding voltage, the minimum voltage required to maintain the on condition of the switch, that is the VH, holding voltage, and corresponding current is the holding current. So once our applied voltage is reduced, this will current and voltage will be reduced naturally, and once the voltage falls below VH or current falls below IH, the device will assume off state. So characteristic from this will now follow this one. এই দিকে এটা reversible নয়. From off to on, it will move this through this negative resistance region, but from on to off, it will follow this one, and then again the reverse characteristics. from off to on, either you will have to apply voltage greater than VBO or some smaller voltage, but in that case an adequate gate pulse should be applied here. That means a triggering voltage is required to make the switch on. So to make the switch off, we are using this switch in the power system. We want to control the power fed to the load, or we want to convert the waveform of the power source. Then to make the device, এই voltage গুলো কি several kilovolt, hundreds of kilovolt. Then and VH is only few volt. So you will have to reduce that large voltage and to make it less than some, say, from it to some thousand of volt, we will have to reduce it to below 1 volt. So that is not, the control is, that is not very easy not, rather it is a complicated situation. Rather, if we just reverse the polarity of the applied voltage, it will readily be in the reverse non-conducting region, and that will drive the device to the off state very fast. কাজে আমার এখান থেকে আমার অপারেটিং পয়েন্ট কমতে কমতে এটা ফলো করবে, it is not, it is a complicated process, rather not at least very straightforward. But if we simply, whatever be our voltage, if we simply reverse bias the, if we simply change the polarity, reverse the polarity of the applied voltage, that means a large reverse bias is applied across the device, the switch will be off. So this technique is called force commutation, where the polarity of the applied voltage is reversed, device will move from on to off. আরো অনেক কিছু টুকটাক তো এই সম্পর্কে বলা আছেই, কিন্তু আজকে আমি গ্লস বলি, নেক্সট দিন কিছু কি মিস করলাম বা ফাইনাল কিছু তো আছে ডেফিনেটলি বলবো। So the main application of SCR is control rectification, as its name implies, silicon control rectification. So what is control rectification? Say this is our line voltage, and if we consider half wave rectification, that means we have applied a diode and a load, so the diode conducts only during the positive half of the supply. So accordingly, we get some, so current through the load will also flow only during the positive half cycle, and we know that if Vm be the peak voltage of this sinusoidal is line voltage, the VDC that we can derive, the DC voltage is given by Vm by pi in case of half wave. If we use two diode in proper circuit, we get full wave rectification, and this negative cycle of the diode line voltage will also appear like this. So we call it full wave rectification, and this VDC gets doubled, twice Vm by pi, and that is full wave rectification. এগুলো তোমরা জানো? জানো তো rectification? Do you know?
Yes, ma'am.
For full wave rectification, it is twice Vm by pi. So say আমি half wave এর জন্য waveform এঁকেছি, so I am discussing this thing. So in this case, VDC that we can derive from that particular AC is always this one. Will depend on the peak voltage of the input AC. But if we use a SCR in place of the diode, then for this Vm, obviously we will choose a SCR for which the in absence of triggering pulse, the breakover voltage of the device must be greater than the peak voltage of this. That means in absence of triggering pulse, the no portion of this AC will make the switch on, so no conduction will take place. You will get zero load, zero current in the load. But for this region, this is our triggering pulse, the gate current that will be applied, the triggering pulse that will be applied to the gate terminal. And now this is the phase difference. The input cycle starts here, but we apply gate current here. Obviously, that should be of desired amplitude. Then what happens? When this gate pulse appears, the device will, the SCR will be on, the switch will be on. So rest of the positive half cycle, the red one, the switch will conduct, will allow this current to flow through the load. So the load voltage appearing across the load, the voltage appearing across the load will be this one, part of the positive half cycle. And the power fed to the load is related to the area under the V-load curve. এই পুরোটা এলে আমার Vm by pi হতো, but a small portion is lost due to this delay. We have intentionally applied this at a later instant. That means this portion, the device switch is not on, so it will conduct only this portion. And once the negative cycle comes, our switch is off automatically. So we get the load voltage like this. So by applying the triggering pulse selectively, if we apply it right at this peak one, we will get only this portion of this load. So the voltage fed to the load will be less. So by applying this, adjusting the instant at which the gate voltage will be applied, that means phase difference of this gate pulse with respect to the line voltage, AC voltage, we can control the switch to conduct the entire positive half cycle. If we apply this trigger right at this point, at 0, then the switch will conduct to the entire positive half cycle, and load fed voltage fed to the load will be, the DC voltage will be Vm by pi. If we apply this here, then the device will not be conducted at all, because the signal, this AC itself is negative. So 0 load will be fed, and in between, for any position, you can vary the DC voltage between these two extreme values, 0 to Vm by pi. So this control load, purpose of this switch was, power switch was to control the power fed to the load. Thus, we can use a SCR for control rectification, to feed the control amount of power to the load from the power source. Clear? Clear নয়? না, আমি অনেক, এটা একটু কমপ্লিকেটেড, আমি তোমাদের 10 মিনিট আগে ছাড়ছি, মাপটা ঠিক হবে। টুকটাক যেগুলো আছে নেক্সট দিন আমি বলবো। তাহলে আপাতত এই ভেবে দেখো কোথাও কিছু বলার আছে কিনা। কিছু জিজ্ঞাসা নেই? অল ক্লিয়ার?
ম্যাম একবার নিজেতে পড়ি, তারপর নেক্সট দিনকে না হয় জিজ্ঞাসা করে নেবো।
আচ্ছা আচ্ছা, ঠিক আছে। সেই জন্য আমি বাকি যে টুকটাক বলার সেগুলো আমি ধরো এসিআর এর আদার অ্যাপ্লিকেশন এই সবগুলো আমি পরের দিন বলবো। আমি গ্রস জিনিসটা, মেইন মেকানিজমটা তোমাদের ক্লিয়ার করবো। ওকে, তাহলে আমি আজকে ছাড়ছি, এসিআর এর বেশি পড়াই নেই। ওকে, ট্রিগারিং মেকানিজম স্টিকম্যান ব্যানার্জিতে আছে, খুব সুন্দর। ওকে, দেন আই এম লিভিং মেটেরিয়ালটা উইথড্র করে নেবো, এইটা সত্যি তোমাদের দিয়ে দিতে পারলে হতো। দেখি আর কি সুযোগ জিজ্ঞেস করতে হবে।